Hi everyone, Caoimhin here from MTU's Blackrock Castle Observatory. If you've been keeping up with our Twitter videos, then you already know a little bit about globular clusters, but we're going to be taking a deeper look at them in this video here, what they are, how to find them, and how better they look, or how much better they look under dark skies. So the sun is just set as we come past 9 o'clock here. We've got Sirius now definitely in the south-southwest and Orion over the southwest. A lot of the objects we've been looking at have been moving towards the west, but that means there is new objects and new constellations to look at over towards the east. So we can see that Leo is now nice and high in the southeast, with Virgo just a little bit lower. We can see a lot more of the constellation Virgo here over the eastern horizon as well. And we will be talking more about Virgo and Leo as we get into Dark Skies Week, which is coming up. But we're continuing to turn over towards the east-northeast. We can see this very bright star reasonably low in the sky. This is Arcturus. It's the brightest star in the constellation Boötes, so we have that constellation here and over here, just under the handle of the plough, our Big Dipper at this time. The later we get in the evening, the higher in the sky it will get, but if you follow the arc here, this curve on the plough, it will bring you down to Arcturus. So there is a little rhyme, arc to Arcturus, and then spike on to Spica, and that will bring you to the brightest star in Virgo, which is still under the horizon. But that's something we'll be able to make use of later in the year. If we keep turning over towards the northwest or northeast, you'll see this kind of triangular shape. This is part of a square, and it's part of the constellation Hercules. So we've got Boötes and Hercules. They're really just starting to come up reasonably timed in the evening as we get later into the year here. Yep, there's the bright star Arcturus. It's one of the brightest. So there are a couple of globular clusters visible over in this direction. One of the most famous, the Great Cluster in Hercules, is of course in Hercules. But there is also another cluster up just above Arcturus, which is part of the famous Messier group, or Messier catalogue. So if we start taking a look in here, we're already starting with all of the light pollution in the city, so we'll have to zoom in very close to start noticing that some of these dots are a little bit fuzzier than others. Luckily, with Stellarium, we can bring up some handy hints. So there we go, just over here, here is M3, and M3 is a globular cluster. So that's a globular or globe-like cluster of stars, and there it is indeed a ball of stars. And we can see this one pretty dense in the middle, but you can still almost tell that they're separate stars. It gets a lot fuzzier out towards the edges and it really stretches out into space. So these globular clusters, they are essentially balls of stars that have rolled up together and started to become attracted together thanks to their gravity. But different ones have, clustered together to different degrees. Some are a little bit tighter, a little denser in the middle. Others are a little bit looser. So we can see here the Great Star Cluster in Hercules. It's definitely very big, really dense there in the center, and really quite dense around the middle before it starts fading out to this thinner, looser shape. So these globular clusters are all over the sky. In fact, if we zoom in a little here, you can see we've got different shapes for different objects in the sky. This little circle with a cross usually means a globular cluster. See, there's another one, M92. In the city, we're going to have to really zoom in to start seeing any globular clusters. Even the bright point-like dot, which can be mistaken for a star, we're not going to see many of them with our eyes here in the city. But we'll push out to the countryside, which always gives us a better view, and straight away we're already getting told where some of those globular clusters are. If I take off the hints again, we'll just make sure that we're looking roughly where M3 should be, just up there. If we start taking a closer look, you can see a fuzzy point. It's a little bit different to the stars around it. It is visible, even with quite small telescopes. And thanks to this, we've been seeing these globular clusters. I keep clicking on a satellite. We've been seeing these globular clusters for quite a long time, and we've been mistaking them for other objects in the sky for quite a long time as well. So there is M3. Charles Messier was a French astronomer who was really trying to find comets, but as he looked around the sky, he kept finding these globular clusters instead, as well as other things in the sky like nebulae and galaxies. There we go, a really dense cluster there, M92. So Charles Messier started putting together this list of objects that kind of looked like planets. They were kind of looked like comets. They were kind of fuzzy sphere shapes, but they weren't comets. They didn't slowly drift across the sky the way a comet does. And that drifting across the sky, it's one of the big ways we tell apart things in our solar system compared to things in other solar systems or in other parts of the galaxy, because they won't move as noticeably from our perspective. So we can see there's a few of the globular clusters there. We have pushed out into the countryside, so we're getting a bit of that glow from the sun. We'll allow that to fade away, and just to give us the best possible view, we're also going to remove the atmosphere, which isn't an option that we have here on Earth. but it will allow us to take a look at these things in the sky without any light, without any interference at all. So we can see there's definitely a few nice ones there. These globular clusters, although a lot of them were discovered by Charles Messier and put on his list, you can see this is M53, we've already seen M92, there's a lot of objects on the Messier catalogue, and a lot of them are globular clusters because of that kind of round fuzzy shape. We find these globular clusters around all galaxies, and they are around the galaxy, they're a little bit outside of it. So this band of light here, our galaxy, the Milky Way, of course, it's made of stars, and some of these stars drift a little bit outside the Milky Way galaxy. They're still orbiting the big central black hole, but they're not as tightly bound to the galaxy as some of the other stars within the arms. So these stars that are floating around the outside of the galaxy, Andromeda has these globular clusters orbiting it as well. The stars outside the galaxy start to cluster together, forming those globular clusters. So we can see here the Andromeda galaxy, its companion galaxy, so this is a dwarf galaxy, it's got its own real center of gravity. It's orbiting around Andromeda almost the way a planet would orbit the sun, or a star or a moon would orbit a planet. But the globular clusters in here, they're more like satellites. They're more like almost like the rings of Saturn, very small objects orbiting around the galaxy. Well, I say very small. They're light years across, but they're far, far smaller than any true galaxies. If we zoom in here, we've got a few galaxies off in this direction. This is the Triangulum galaxy. And the Triangulum galaxy has globular clusters around the outside as well. So Charles Messier discovered a lot of these, but it was another astronomer named Harlowe Shapely that figured out how useful they could be. By looking at the distribution of these clusters around other galaxies, it was discovered that we see more of them towards the center of the galaxy, which is roughly down in that direction. We don't see as many of them when we're looking out towards the edge of the galaxy. So by looking at the distribution of these globular clusters in our galaxy compared to other galaxies, we were able to get an idea of where we were in our galaxy. We're about 3/4 of the way from the center, we're about 1/4 of the way out to the edge. So by looking at the distribution of globular clusters around other galaxies, we were able to study the distribution around our galaxy and infer our position within the Milky Way. This is before we had the ability to really see around the black hole in the center of our galaxy, but by using other methods, we have figured out that Harlowe Shapely was pretty much spot on. We are just about 3/4 of the way out from the center and 1/4 of the way to the edge. So this is one way that we can learn more about our own place in our galaxy by studying these things in other locations. So those are the globular clusters, and there's some fantastic things that you can see even with a telescope or binoculars. So that is what we're going to do next. We're going to point over towards that great cluster M3 over there in Hercules. You can see we're only starting to take a closer look here, and already it's becoming more visible. Now I will flick on these symbols so that it definitely selects what I want to look at, and we'll use the ocular mode. Well, this is through a fantastically large telescope, a Meade LX200, which of course gives an amazing view. But if we go back down to a very, very small telescope, a generic telescope, we take off these really helpful oculars, which increase our view. We'll take off these Barlows. We're just using a small basic telescope without that much added on to help at all. And you can already see that this is a cluster of stars. It's not just one point. In fact, here we are with a nice pair of binoculars. This is a very good pair of binoculars. Definitely a globular cluster. This is, quite a small pair of binoculars, and you can definitely see the fuzziness here as well. Again, this is out in the countryside. If we quickly bring ourselves back into the city, light pollution is going to affect especially the fuzziness. So we can't quite see the edges of the cluster anymore, but we can see that that's not just one star in the center. There's an area of light here, not just a point. So these are globular clusters, and we're going to be taking a look at a few of the deep sky objects this coming week and how they look different under dark skies compared to our light polluted skies in order to emphasize dark skies for Dark Skies Week. But whether you're in the city or the countryside, with a good pair of binoculars even, you can find these globular clusters in the sky. So I hope you get the chance over the coming weeks.